Here is collection of few trigonometric equations extremely important from examination point of view for grade 12 students. I am Anil Kumar. Welcome to my YouTube channel. We have more than 17,000 videos absolutely free for you. We are going to discuss four trigonometric equations in this particular video. Also explore the playlist for many more examples of similar kind. You can make a note of these questions, answer, and then look into my suggestions. In case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Our students are right there on the top, getting excellent marks and admission to the best universities. So let's begin with the solutions. In these problems, we need to solve and provide exact solution or round to hundreds. Since the domain of solution is from 0 to 2 pi, you should use the calculator with radians as the setting. Question number 1 is 2 cos square theta plus cos theta minus 1 equals to 0. So it's like a quadratic equation, right? So we have 2 cos square theta plus cos theta minus 1 equals to 0. We can factor it, product of minus 2, sum of 1. So let's factor. So we got 2 cos square theta plus 2 cos theta minus cos theta minus 1 equals to 0. Taking 2 cos theta common, we get cos theta plus 1. Taking minus common, we get cos theta plus 1 equals to 0. And now cos theta plus 1 is common. So that gives us 2 cos theta minus 1. So, and that too equal to 0, right? So the cos theta value could be what? From the first factor, cos theta is equal to minus 1. From the other one, cos theta equals to half. Now, within this domain of 0 to 2 pi, as you know, the cosine function is kind of like what? It starts with 1, right? And then goes like this. Right. So when we are looking at minus 1, there is only one solution, and that is the point. So from 0 to 2 pi, the one of the solutions is pi, right? And that is for minus 1. So we get one solution, which is, we can write theta equals to pi. The other one is half. To get this solution, it is a good practice to sketch right angle triangle, which gives you exact value, right? So we know 1, 2, and square root 3 are the values when this angle here is pi by 3. Now, within 0 to 2 pi, as you can see, there are two solutions, right? And these two solutions are actually in quadrant 1 and in quadrant 4. The angle being pi by 3, right? So these are your solutions. So one is pi by 3 and the other one is 5 pi by 3, correct? So we have two solutions here. So we can write down theta equals to pi by 3 and 5 pi by 3, correct? So we get two different solutions, as you can see, pi by 3 and 5 pi by 3. Perfect. So I hope this strategy is clear for these quadratic type trigonometric equations. Remember your special triangles, and if required, solve with the calculator. Here is the second question, which is, let's copy the question, which is 3 cos square theta minus 1 equals to 0. Rearrange. So we get 3 cos square theta equals to 1, or cos square theta equals to 1 over 3, or cos theta equals to plus minus 1 over 3 square root. Correct. So 1 over square root 3 basically. Now for this, what can work? Well, plus and minus means that we are looking for four solutions, right? So let me once again share with you this. Now 1 over square root 3, the special triangles do not really work out. So in this particular case, we need to use the calculator. So let's find the related acute angle. So let me write down cos of alpha, where alpha is the related acute angle equal to 1 over square root 3. So, so we want to find shift cos inverse, right? 1 divided by square root 3. So, so we found alpha as cos inverse 1 over square root 3, and we got this related acute angle alpha as 0.955. So because it is 0.955, I'll round it to 0.96 since we have to write answers to the hundreds, right? Correct. So we got one angle here, and this angle is the angle alpha, right? Since we have plus and minus, you can see that there are four solutions. So the four solutions can be shown on this particular graph, and therefore let's write down what theta could be, right? So theta is the related acute angle 0.96, and then it is pi minus 0.96, pi plus 0.96, and also 2 pi minus 0.96. You get the idea, right? Correct. So let's do this because shift. So I'm using pi now. Shift pi minus 0.9. Let me use the value 55 and then we'll round it. Okay. So it gives me a value which is equal to. So one is, of course, theta equals to 0.96. The other one is 2.186. I'm rounding to the hundreds. Now we have pi plus zero point 0.9. I'm adding 55, okay? And so what I get here is 4.096. So I'll write this as 4.10. And then we got 2 pi. So 2 times pi minus 0.955 I'm using. And I get 5.328. So 5.33 radians, right? So all these are in radians. So these are the angles in this particular case. I hope you are with me. So we have seen two examples in one. We use the special triangle, and here we use the calculator, rounding our answers to the nearest hundreds. So now here is question number 3 for you. We have similar equations, but this time in sine, right? So bring the terms together, you get 2 sine square theta plus 5 sine theta minus 3 equals to 0. 2 times 3 minus will be minus 6. We need 5. So let's factor. So we get 2 sine square theta plus 6 and 1 works for us, right? So 6 sine theta minus sine theta. That takes care of 5 sine theta, right? And now we are going to take 2 sine theta common in the first two factors, giving us sine theta plus 3 minus common gives us sine theta plus 3 equals to 0. Now sine theta plus 3 is common factor, and we are left with 2 sine theta minus 1 equals to 0. So this gives us sine theta equals to minus 3, and the other one gives us sine theta equals to half. Now sine theta value can be between minus 1 and plus 1, so there is no solution for this one, right? Not valid. But the other one, We can again sketch this particular right triangle, and for half, we can see that the angle is pi by 3, right? Perfect. So, and we also know sine is positive in two quadrants, and therefore positive half means we are looking into these two solutions where the, sorry, pi by 6, right? Not 3, 6. So we have pi by 6, and this angle here will be 5 pi by 6, correct? Great. So theta is equal to pi by 6 and 5 pi by 6, correct? Pi by 3 is this angle, right? Perfect. So we got the two solutions within the given domain of 0 to 2 pi. The last question here is in tan. We are given 3 tan square theta minus 2 tan theta minus 1 equals to 0. Now again, you can factor this. So we get what? So we get 3 tan square theta. You can write this as minus 3 tan theta plus tan theta minus 1 equals to 0. 3 tan theta is common between the first two factors. You get tan theta minus 1. And here we have tan theta minus 1 equals to 0. Now tan theta minus 1 is a common factor. So we get 3 tan theta plus 1 equals to 0. That gives you tan theta equals to 1 as one solution. Or we get tan theta equals to minus 1 over 3. Now tan theta equals to 1 is there in, we got two values, pi by 4, of course, one of them. And tan theta is positive in quadrant 1 and in 4. So we get two answers. One is pi by 4, the other one is 5 pi by 4. Clear? Correct. So we get this as theta equals to pi by 4 and 5 pi by 4. Now tan theta equals to minus 1 over 3 means we have to use the calculator. So that gives us theta equals to tan inverse of 1 over 3. Rather, we'll actually find the related acute angle and then use the strategy to find the answer. So we'll do shift tan inverse of 1 divided by 3, and in radians we get 0.3217, right? Let me write 32, right? Great. So if alpha is 0.32, then what should be the angle theta equals to? So angle theta, which will be in quadrant 2 and 4, should be pi minus 0.32, right? Which we can calculate, and equals to 2 pi minus 0.32, correct? You can calculate these answers. So pi minus 0.32 is equal to 2.82, and 2 pi minus 0.32 is equal to 5.96. So I hope you have understood how do we calculate the angles from the related acute angle to round it to two decimal places. Now, let us take up another set of questions to master these strategies. Now we are taking four examples where the equations will be solved by factoring. We are working in the domain of 0 to 2 pi. Solve equations, provide exact solution, or round to the hundreds. You can use special triangles to find the exact solutions. Otherwise, use calculator to calculate the answers in radians. So the settings of the calculator should be in radians. Let's begin with the very first question, which is cos theta cosecant theta equals to 2 cosecant theta. Let's rewrite the equation. Cos theta cosecant theta equals to 2 cosecant theta. Now, at this stage, please do not cancel cosecant theta since that will be a mistake, eliminating few solutions. We'll see it soon. Bring the terms together. So rewrite as cos theta cosecant theta minus 2 cosecant theta equals to 0. Now cosecant theta is common. You can factor cos theta minus 2 equals to 0. So now, using the properties of zero multiplication, we have two solutions here. We can write cosecant theta equals to 0, or we can say cos theta equals to 2. As you know, cos theta cannot be 2, so we have no solution for this one. Cosecant theta equals to 0 also does not have any solution, since you know that the value of cosecant theta is either less than minus 1 or greater than 1. So here also we have no solution. So in this particular example, we do not have any solution for the given equation. Now let us take up the second question, which is 4 sine theta tan theta plus 20 sine theta minus 3 tan theta equals to 15. You can bring the terms together and factor. Correct? In the first two terms, we have 4 sine theta as common. We are left with tan theta plus 4, 5, right? 20 divided by 4 is 5. Now we can take 3 common. We get tan theta plus 5 equals to 0. Now tan theta plus 5 is common, and that gives you 4 sine theta minus 3 equals to 0. So we have solution for tan theta equals to minus 5 or sine theta equals to 3 by 4. Within the domain of 0 to 2 pi, tan theta is minus 5 means you are in quadrant 1, you are in quadrant 2 or 3, right? So we have two solutions here. Minus means we are looking at the quadrant 2 and 4. For sine theta to be positive, we are looking at the quadrants 1 and 2. So we have four solutions within the domain of 0 to 2 pi. Now in each case, we should find the related acute angle alpha and then get the other solutions, right? So for tan theta equals to minus 5, I'll write down tan alpha equals to 5, right? So we'll find the related acute angle in quadrant 1. Setting the calculator in radians, we get shift tan, that gives us tan inverse of 5, and we get 1.373. So I'm going to round this as alpha equals to tan inverse of 5, which is 1.37. So what is going to be theta, which is between 0 to 2 pi? So the two solutions are, one is pi minus alpha, the other one is pi 2 pi minus alpha, correct? So theta equals to pi minus 1.37 and theta is also equal to 2 pi minus 1.37. Let's see what do we get. So we got pi minus 1.37, that gives us the value of 1.77, and then 2 pi, 2 times pi minus 1.37, and that gives us 4.91. So these are the two answers from the first factor, tan theta plus 5. Now let's find the other two answers from the second factor, which is sine theta is 3 by 4. Now 3 by 4 is positive. We can find angle alpha. So sine theta equals to 3 by 4. So alpha equals to sine inverse of 3 by 4, which is, let's use the calculator once again. Shift sine inverse 3 by 4. And that gives us 0.848. I'm going to write this as 0.85. So alpha is 0.85. So the two angles for theta will be one in quadrant 1, which will be 0.85, and the other one will be pi minus 0.85, correct? Or is equal to, let's calculate, pi minus 0.85 gives us 2.29. 2.29. So that is how we get solution of this particular equation. So we have four answers. Theta is equal to 1.77, 4.91, 0.85, and 2.29. Make sense? So that is how we will be answering this particular question. Now let's move on and take up the next question, which is secant square x minus 2 tan square x equals to 0. Secant square x minus 2 tan square x equals to 0. Now 1 plus tan square x is secant square x. We can use that identity, right? So I'll replace secant square x as 1 plus tan square x minus 2 tan square x. So we're left with 1 minus tan square. Tan is 1. So we have pi by 4, 3 pi by 4, 5 pi by 4, and 7 pi by 4. So we get the value of x as equals to pi by 4, 3 pi by 4, 5 pi by 4, and 7 pi by 4. Perfect. So I hope you have understood the method of solving it. With that, we have solved three questions. I hope you are enjoying this journey of learning. Now we'll switch on to different set of questions where we have double angle, and these equations, when simplified, take a form of quadratic trigonometric equation. Let us see how to solve them with Anil Kumar. We have few equations here, four of them, involving double angle. Now, when you simplify these equations, they turn out to be quadratic equations. And based on that, the question here is, solve equations, provide exact solution, or round to the hundreds, since you might have to use the quadratic formula and get a decimal value. Great. So make a note of these four important questions from test point of view. We'll take them one by one. Well, in case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Our students are right there on the top, getting admission to the universities even with scholarship. Great. Question here is 5 cos 2 theta minus cos theta plus 3 equals to 0 on the domain 0 to 2 pi. So cos 2 theta basically has three different formulas, as you know. We'll use cos 2 theta equals to 2 cos square theta minus 1 to write this quadratic equation in cosine. So the equation, which is 5 cos 2 theta minus cos theta plus 3 equals to 0, now becomes 5 times 2 cos square theta minus 1 minus cos theta plus 3 equals to 0. That is 10 cos square theta minus 5 minus cos theta plus 3 equals to 0, or 10 cos square theta minus cos theta minus 2 equals to 0. Now we need to factor this. 10 times 2 minus 2 will be minus 20. We need sum to be minus 1. So 4 and 5 work for us. So we'll write this as 10 cos square theta minus, let's say, 5 cos theta plus 4 cos theta. That gives me minus cos theta minus 2 equals to 0. Factor out 5 cos theta. And that gives you 2 cos theta minus 1 plus, we can factor out 2 from here. So we get 2 cos theta minus 1 equals to 0. Now 2 cos theta minus 1 is common. So we get 5 cos theta plus 2. Correct. So this gives you two different factors which should be equal to 0 when multiplied. So using the zero principle, we can say that 2 cos theta minus 1 equals to 0 means cos theta equals to half. And the other one is 5 cos theta equals to 2. Plus 2 equals to 0 means cos theta is minus 2 by 5. Correct. So now, for cos theta equals to half, we'll have two solutions which will be in which quadrant? Well, this should be in quadrant 1 and in 4, right? Since you know cos is positive in these quadrants, you can write down the cos rule. Secondly, for half, we can also use special triangle. We need not use calculator. And the angle is pi by 3. Pi by 3 gives you half. And therefore, we know theta is equal to pi by 3 and this angle, right? Which is 5 pi by 3. So we got these two solutions for one of the factors. Now the other one, theta equals to minus 2 by 5. Now that minus 2 by 5 will be in quadrant 2 and 3. So let's find the angle alpha first, right? So we're going to equate cos alpha equals to 2 by 5, right? And find alpha as equals to cos inverse 2 by 5. Use calculator. Setting should be in radians, right? So we have shift mode, radian setting, right? And now do cos inverse. Shift cos inverse within brackets 2 divided by 5. Bracket close gives me a value 1.159. We need to answer in hundreds, so I'll round it to 1.16, right? So I get 1.16 radians as my answer. So the two values will be what? So we get this theta as equal to pi minus 1.16, and the other value is theta will be pi plus 1.16, correct? So let's find this out. So I'll use a different ink here, red one, to get these two answers. So when I add pi to it, I get 4.30. And when I do pi minus 1.16, I get 1.98. Correct. So, as expected, we have got four solutions to this particular equation. So, these are the four solutions. So, I hope you have understood the strategy of solving trigonometric equations like this. Now, based on this solution, I like you to answer the other three questions. I'll be uploading their videos soon. However, I'll appreciate if you could write down the answers and then match with my solutions, which will be uploaded by tomorrow. Let us understand strategies to solve trigonometric equations. I am Anil Kumar. Welcome to my YouTube channel, where you find thousands of videos related to the questions which you really need solutions for. In this video, we've taken up quadratic trigonometric equation. The equation doesn't really look like a quadratic trigonometric equation. However, when we solve, you'll see how it gets transformed. So this is question number 2 from our playlist. The question here is solve equation, provide exact solution, or round to hundreds. Very important instruction. For answering questions in exam, you have to look into the conditions. Question 2. 10 cos 2 theta minus 8 cos theta plus 1 equals to 0 on the interval 0 to 2 pi. So let's see how do we solve it. Well, when we talk about cos 2 theta, then it reminds us three different formulae. However, we have minus 8 cos theta. That means we should write cos 2 theta as what? Definitely 2 cos square theta minus 1. Makes sense, right? So let's begin the solution now. So question number 2 here is 10 cos 2 theta minus 8 cos theta plus 1 equals to 0. Writing cos 2 theta as 2 cos square theta minus 1, what do we get? Open the bracket. 20 cos square theta minus 10 minus 8 cos theta plus 1 equals to 0, and rearrange. So we get 20 cos square theta minus 8 cos theta minus 9 equals to 0. Now see, you have a quadratic equation. Perfect. That's what we meant when we said quadratic trigonometric equation. So one way is to factor. We are looking for a product of 20 times 9. So let me write down. We're looking for minus 20 times 9. And the sum, this is product of two numbers p and q, whose sum should be equal to minus 8. So the terms could be 18 and 10, right? How do we get them? 20 can be written as 10 times 2, right? So, of course, we can have 18, 9 times 2, and then 10. Perfect. So, let's rewrite. So we get 20 cos square theta minus being a bigger number, so minus 18 cos theta plus 10 cos theta minus 9 equals to 0. Now we can factor 2 cos theta, right? And we get 10 cos theta minus 9. We already have 10 cos theta minus 9 equals to 0. So final stages of factoring, 10 cos theta minus 9 can be factored out, and we get 2 cos theta plus 1. Great. Let's continue from here on a new page. So we'll do 10 cos theta minus 9 as one of the factors, and the other one is 2 cos theta plus 1, right, equals to 0, correct? So let's check, right? So here you can see that the coefficient is 1, right? And 10 cos theta minus 9 is common. So we get 2 cos theta plus 1, right? So we get 2 cos theta plus 1 as the other factor, 10 cos theta minus 9 as one of the factors. Now, clearly, using the zero principle, we can equate each factor to 0. And so we get cos theta equals to 9 over 10, or we get cos theta equals to minus half. So that will give us a couple of solutions, as you can see from here. So you can use a calculator to find when cos theta is 9 by 10. For cos theta equals to minus half, we can use a special triangle. Let's calculate this out. So what we have here is cos theta is 9 by 10 positive. So that means we are looking for two solutions, one in quadrant 1, the other one in quadrant 4. So let's find the related acute angle, which will be theta equals to cos inverse of 9 by 10. So let's figure out shift cos inverse. We are working in radians. 9 divided by 10 or zero point 0.9. So we get theta equals to 0.451. Since we want to round it to hundreds, I have written 0.45. That should work, right? Great. So this is one of the solutions. The other one will be in quadrant 2. So that is one angle. The other one will be 0.4145. We have to take away from 2 pi, right? So 2 pi minus 0.45. So let's do that. Minus, and we get 5.83, right? So two different values, which is 0.45 and 5.83 are the solutions, right? So we can write down here. So theta equals to 0.45 and also 5.83. Makes sense. The other one, we can use a special triangle, as you know, 1, 2 square root 3 for angle being pi by 3. Since cos theta is negative, we know that the solution lies in quadrant 3 and in 2, right? The angle being pi by 3 as an acute angle. So here theta is pi plus minus pi by 3, correct? So the value of theta is this, which is 2 pi by 3, or that, which is 4 pi by 3, correct? We got these two solutions also. So theta is also equals to 2 pi by 3 and 4 pi by 3. So these are the four solutions for the given equation. Makes sense, right? So as you can see, we provide exact solutions and round to hundreds as required in the question. So I hope the concept is absolutely clear. So these are the four solutions in the domain where theta is between 0 to 2 pi. Perfect. So I hope you have understood. We found the related acute angle. After that, we got the two solutions. Here also, we found the related acute angle. After that, we got the two solutions. So that is how you solve a trigonometric equation. I hope all the steps are absolutely clear. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. In this playlist, we have many questions from past test papers. It is worth exploring a bit more. That will help you in your own test papers. Strategies to solve double angle trigonometric equations with ease. I am Anil Kumar. Welcome to my YouTube channel. This is the channel for you where we post questions almost daily based on your request. You want to understand how do we solve trigonometric quadratic equations. Always in a test paper, you'll find one of these. So, question number 3 here is 4 cos 2 theta plus 10 sin theta minus 7 equals to 0. We need to solve when theta is between 0 to 2 pi. It doesn't look like a quadratic equation, but soon it will take that form since we know what is cos 2 theta, right? Writing cos 2 theta in terms of sine theta will be 1 minus 2 sine square theta, correct? So that gives you the quadratic form in sine. So let's do it. Let's copy the question first, which is 4 cos 2 theta plus 10 sine theta minus 7 equals to 0. Writing cos 2 theta as 1 minus 2 sine square theta plus 10 sine theta minus 7 equals 0. Open the bracket. 4 minus 8 sine square theta plus 10 sine theta minus 7 equals to 0. So I like to take all the terms to the right hand side. That's good. So we get 8 sine square theta minus 10 sine theta. 4 minus 7 is plus 3, minus 3. But when you take it to the other side, it becomes plus 3. Correct. So what are we looking for now? To factor this quadratic form of trigonometric equation is product of 8 times 3, which is 24, and sum of minus 10. So clearly, minus 6 and minus 4. Right. So we can rewrite this as 8 sine square theta minus 6 sine theta minus 4 sine theta plus 3 equals to 0. Factor by taking out 2 sine theta common, we get 4 sine theta minus 3, and already we have minus 4 sine theta minus 3 equals to 0. So 4 sine theta minus 3 is common factor. We get 2 sine theta minus 1 as the other factor equals to 0. So clearly, we have two factors which can be equated to 0. So we get 4 sine theta minus 1 equals to 0 means sine theta equals to 1 by 4. We can use calculator to find these two values. Clearly, sine theta 1 by 4 means we are looking for solutions in quadrant 1 and in 2, right? So let's find this. So what is the related acute angle, right? So theta equals to sine inverse of 1 by 4, which is, so setting should be in radians. Sine inverse of 1 divided by 4, 0.252. So we'll write to 0.25, round to 2 decimal places. The other value is pi minus that, right? So the other value is 0. I should write pi minus, right? So let's do pi minus 0.25, which is minus, let's do it. And we get 2.888 or 2.89. So sine 1 by 4 gives us two possible solutions, which are, as you can see, 0.25 and 2.89. The other two solutions we are going to get from the second factor, which is 2 sine theta minus 1. So let's go to a fresh page, right? So we'll equate 2 sine theta minus 1 equals to 0, means sine theta is half. So here we can use a special triangle, as you know, which is 1 to square root 3 for angle of pi by 6, right? Half means we are looking for positive value, right? So Again, the solutions will lie in quadrant 1 and in 3. Pi by 6, right? So one of the solution is pi by 6. The other one is 5 pi by 6. So here theta equals to pi by 6 and 5 pi by 6. Makes sense, right? So in all, since we had two solutions earlier from the factor 4 sine theta minus 3, which is 0.25 and 2.89, so theta equals to 0.25, 2.89, and here we have the values pi by 6 and 5 pi by 6. Correct? So these are the four solutions for the equation to be true within the domain of 0 to 2 pi. Perfect. So that brings us to the last problem, question number 4 to be solved. Remember that these are the questions posted by our students, and I hope the solution which we are discussing will be helpful for most of you. Feel free to post your questions so that you can have solutions from your own channel. Enjoy the journey of learning with Anil Kumar. Now, let's look into the solution of the question, which is sine theta equals to minus cos 2 theta. Now, since we have cos 2 theta, we could write it in terms of sine square theta. So, what is cos 2 theta equals to? It is 1 minus 2 sine square theta. There are three different formulae, but since we have sine theta, we'll prefer to use this form. Great. So, let's rewrite this as sine theta equals to minus 1 minus 2 sine square theta, which is bringing them all together, 0 equals to, open the bracket, we could write this as 2 sine square theta, minus and minus makes it positive, minus sine theta minus 1. Makes sense. We can now factor this product of minus 2 sum of minus 1, which gives us 2 sine square theta minus 2 sine theta plus sine theta minus 1. Take 2 sine theta common. From the first two factors, you get sine theta minus 1. We already have sine theta minus 1 as the other factor. So, the factoring is completed when you take sine theta minus 1 as a common factor, and 2 sine theta plus 1 becomes the other factor. Now we are going to apply the zero principle. Each factor should be equal to 0. Makes sense, right? So let's equate sine theta minus 1 equals 0 or sine theta equals to 1. Now sine theta within the interval of 0 to 2 pi is 1 only for pi by 2, right? So we get from here theta equals to pi by 2. The other condition is 2 sine theta plus 1 equals to 0. That means sine theta equals to minus half. To get a solution here, we are looking at a triangle, special triangle, which for pi by 6 gives us my half, right? Since we want minus, that means we are looking for angles in quadrant 3 and 4. Related acute angle, alpha being pi by 6. So the solutions are clearly 7 pi by 6 and 11 pi by 6, right? So we get two solutions, which is 7 pi by 6 and 11 pi by 6. Makes sense. So definitely we have three solutions to this particular problem. I hope all the steps are absolutely clear. Feel free to write your comments and share your views. Thanks for your valuable time and all the best.